Okay, so the very first topic that we will review from Chemistry 20, Science 10/Chemistry 20, is the periodic table. Periodic table is a way that we organize all the elements that are found in our world. There are about 118 elements that are in our world, and then those elements are organized into columns and rows. Uh, the columns and the rows have specific characteristics, which we will talk now. The very first scientist to organize those elements into the table was a Russian scientist known as the Mendeleev. And at the old times, actually, the periodic table had the specific name as Mendeleev's table. And the reason that he did this, just out of the curiosity, is that he was a mathematician, so was a math professor at University of Moscow, and then he didn't have enough students on his course. So they gave him a Chemistry 101 to teach. And then on that Chemistry 101, he saw that all the elements were not organized. So what he knew the best was patterns. Therefore, without knowing the depth of, of the structure of the atom, he organized them based on the increasing mass. So he saw that which of the elements has the less mass, and then the first one was hydrogen, and then he moved to which one is the second, helium, and which one is the third, lithium, beryllium, and so on and so forth. So he organized them into the increasing mass, and he noticed that after certain numbers, the chemical characteristics were similar to each other. So this is how we created the groups and the periods. So periodic table is even in your textbook, or you can find the data booklet, which starts with periodic table on D12, uh, is organized into groups that are everything that is on the vertical. So everything that is on the vertical, and in periods, so that is in the horizontal. Horizontal. So now when we are dealing with the vertical, what do we notice in the elements that are on the same group is that the electrons that are in the outer shell is the same. So the number of electrons in outer shell is the same. So we see that everything that is in group 1, let's say, it's the same. In total, we have 18 groups. So you see in your periodic table, if you refer to the periodic table, you start 1A is the first group, and then 8A is the 18th group, which starts with helium and then continues with neons, argon, and krypton, which are known as the noble gases. When you take a look at the periodic table, you will notice that periodic table view is something like this. And then you have a disconnection somewhere in here where a bunch of elements are shown here. Usually 2 rows of the elements are shown here. So those are elements from 89 to 104. And as I said, in total, there are about 118 elements that are established to be known as the elements of all of the elements that are in our world. And when we are looking at the periods, which are the horizontal, the rows, then what we notice is that they have the same numbers of the shells, that the electrons, same number of shells that electrons are distributed at. Because electrons if we have an element that has, let's suppose, 16 electrons, they are not all in one place. So atom has the nucleus, which has protons and neutrons, and then the electrons are distributed into the outer shell. The most inner shell of the atom is able to carry only 2 electrons, and then the second one is able to carry 8, the third one is able to carry 8, and then it goes into more if you take chemistry in university. So there are more into it. However, when we have let's say that we have an element that has 16 electrons, an atom that has 16 electrons, then what we notice is that on the first shell we will place 2. So if we have 16 electrons, then on the first shell we'll place 2 electrons. On the second shell we'll place 8 electrons. So 2 plus 8 is equal to 10. And then on the third we will have 6 electrons to complete the total number 16 electrons, because 2 plus 8 plus 6 is equal to total of 16 electrons. So we are, you should imagine the shells as you are shuffling the electrons into those shells, and you cannot carry more than what the shell can handle. Okay? So now when every element that is on the same period, and the period starts with 1, 2, 3, 4, 5, and they are horizontal rows, those have the same number of shells. So if we are on period 3, which starts with sodium, magnesium, and then goes to aluminum, silicon, phosphorus, and so on, the number of shells that those elements, those atoms have is 3. So you can distribute the electrons that those elements have only on the 3 shells, in 3 drawers per se. Periodic table is divided into metals and non-metals. As you notice here, the periodic table has, in every periodic table that you will see, the periodic table has something that we call it a staircase, and it is bolded, and this is where the metals and non-metals are divided between each other. Whatever is here on this area is considered to be a non-metal, and whatever is on the other area is considered to be metals. And within metals, we have alkali metals, earth metals, and transition metals. But they, in a large group, they are all metals. In general, metals are able to, or are willing to, give the electrons of the outer shell, and non-metals are wanted to, in general, to get those, to receive those electrons in order to complete the outer shell with 8 electrons, which is known as the octet rule. Okay, if you take a look at the periodic table, you will notice that each element has a bunch of information, a bunch of numbers, which we will see and analyze here. So when you see an element, pick any. It doesn't really matter which element you are picking. I will pick aluminum. So aluminum, it has with large letters, it has the symbol of it. The symbol of the element is usually one letter, two or three, especially for the last elements of the periodic table, we see them with three letters. But in general is with one, two, and sometimes with three letters. Always the first letter is capital, and then it's followed by the lowercase letters. The symbol is the same for everyone in the world. So it doesn't matter where you are going. You are staying in Canada, you are going to France, you are going to Germany. Aluminum will always be AL. The name of the element is in the language that country has. And in our case, you will see, since Alberta has as a first language is English, then you will see the periodic table in the name of the elements on the periodic table in English. So usually the name is right below the element. And some international periodic tables do not have the name at all, just have the symbol. So aluminum. Okay. Okay. And then at the left corner of the box of the element, we have a number. Okay, so this number for aluminum is 13, and this number is nothing but it's known as the atomic number. Atomic number. What atomic number is saying that we have what is the number is telling us what is the number of protons. Number of protons in the nucleus. Number of protons of the element doesn't change. So you will see the number of electrons and number of neutrons do change because we have isotopes and we have ions, but the number of protons doesn't change. If in one element, if the number of protons changes, then you are at the next element. Because see here, you have aluminum is 13 and silicon is 14. That means that if you are increasing the number of protons, then you are moving to silicon. Okay. Then another number that it's very, we will use it a lot is a number that is usually below the name if the name is, or below the symbol if the name is not shown. And that number is with decimals. So here we have a number that for aluminum in our case is 26.98. And this number is known as the atomic mass. If the atomic number is a whole number, it's always whole number, because you cannot have 0.5 protons in a nucleus. Okay. Atomic mass is with decimal, it's a decimal number. Even if it is 00, still you will see a decimal. So for fluorine, let's say, or oxygen, 16.00 or 19.00. It's because it's telling us, it's an indication as to it's not the atomic number, but is atomic mass. And it is the units for atomic mass are grams per mole, which are telling us that you need, in the case of aluminum, 26.98 grams of pure aluminum to have 1 mole of aluminum. And 1 mole is an additional unit used in chemistry a lot, because if we are dealing with 1 molecule, then the mass of 1 molecule will be too small. Therefore, we have added a new unit just to make it more perceptional to our brain as to what do we have there. Beside this information, there are plenty of information there, like the most common charges that the element has or the atom has, or the electronegativity. However, for the purposes of what we will focus on chemistry 30, we will not need those, especially the boiling point or the melting point or we will not deal with those kind of things into chemistry 30. This makes